Okay, so for our last two problems, we're going to be going from rectangular to polar. So we're going to be going from rectangular as an xy to polar r theta. So we have two other formulas we're going to use for this. So they come from that same picture that I went over earlier. Let me go back to that. So this picture that I drew here, if you were to turn this into Pythagorean theorem, the r squared, so the hypotenuse, would be equal to x squared plus y squared. So see, x squared plus y squared equals r squared. That's one formula that you're going to use. And then the other formula is tangent theta is y over x. Okay, we know that's a true statement, but also from this picture, we did tangent from SOHCAHTOA is O over A, so opposite over adjacent. So that's where those formulas come from. So r squared equals x squared plus y squared, and tangent is y over x. So we want to find two sets of polar coordinates for the rectangular 1, -1. So like I said, I like to think about this. Right now we have rectangular, we have x and y. We're finding r and theta is what we're missing. So looking at our formulas, I'm going to start with my r squared equals x squared plus y squared. So r squared is what I need. My x value is 1. My y value is -1. So r squared is going to be 1 plus 1. R squared is 2. So my radius is going to be the square root of 2. Alright, then for the next part, we're using tangent theta equals y over x. So tangent theta equals y. Y is -1, x is +1. Okay, something you have to be careful with. This negative has to stay with the y value. Okay, so the y value has to be negative. Okay, you can't go anywhere like it normally can. So think about on your unit circle when you have 1 over 1. That normally happens when you have square root of 2. So I'd have to have negative square root of 2 over 2 and positive square root of 2 over 2. This is the y value, this is the x value. So take a look at the unit circle. You're looking for when you have a negative y value and a positive x value. So if you look here at 7 pi over 4, that's where we would have a tangent value of -1, but the y is negative. So the theta value that goes with that radius is 7 pi over 4. Okay, so the point, the rectangular point here is the square root of 2, 7 pi over 4. That is 1 point. Now, the direction said give 2 points. So remember, we can write an infinite number of points. So for this, I'm going to do, you can really do whatever point you want, but I'm going to do the backwards point. If I do the backwards point, I would make this -2. You already have your unit circle. 7 pi over 4, you see, connects with 3 pi over 4. So 3 pi over 4 would be your other point that you are going to use there. Okay, so for our last problem, we want to take the point -1 square root of 3, and that is in rectangular form, so that's x and y, and we want to put it in polar form, so we want to find r and theta. So if we're going from rectangular to polar, we're going to be using r squared equals x squared plus y squared, and r squared is what we're trying to find. X is -1 squared. Y squared is the square root of 3 squared. So we're going to have 1 plus 3, so r squared is 4, which means our radius here is going to be 2. The other formula we use for going rectangular to polar is tangent theta equals y over x. So tangent theta equals y, which is positive square root of 3, and x, which is -1. Remember, that negative has to stay with the x value. So that will appear on our unit circle. So if we look at our unit circle, remember this will appear when we have the square root of 3 over 2 on top, and then this would be -1/2 on the bottom. So this is our y, this is our x. So on your unit circle, you're looking for when you have an x value of -1/2 and a y value of the square root of 3 over 2. That's positive. So that happens at 2 pi over 3. So my polar point here is 2 pi over 3. Now I did not say you had to give more than one answer here, so that answer would be fine. But remember there's an infinite number of answers. Another answer you could give, though, if you wanted to give the backwards answer, it would be negative 2, and then if you look at your unit circle at 2 pi over 3, directly across from that or backwards would be the 5 pi over 3. So you could also have written negative 2 and 5 pi over 3. Okay, so that's how you change points, polar points into rectangular or rectangular to polar. In our next lesson that we'll be doing, we'll be changing equations instead of just points, but we'll be using those same formulas, the r squared equals x squared plus y squared, tangents y over x, those formulas that we used today.